Good morning everyone, my name is Paras Kori and the topic that I'll be presenting today is non-token based algorithms in distributed computing. My roll number is 15 and our supervisor is Professor Shreya Patankar. Now the next slide or the first slide will give you an outline about what the presentation is going to be about. So first we'll get an introduction about what non-token based algorithms are, and the two prominent non-token based algorithms are Lampert's algorithm and Ricart-Agrawala algorithm. So let's get an introduction about what non-token based approach or algorithms are. So in non-token based algorithms, a site communicates or a node communicates with other nodes in order to determine which node should execute critical section next. This requires exchange of two or more successive rounds of messages among sites. This approach uses timestamps instead of sequence number to order requests for the critical section. Whenever a site or a node make request for critical section, it gets a timestamp. Timestamps is also used to resolve any conflict between critical section requests. All algorithms which follows non-token based approach maintains a logical clock. Logical clocks get updated according to Lampert's scheme, and the two most prominent examples are Lampert's algorithm and Ricart-Agrawala algorithm. So basically in non-token based approach, tokens aren't involved, but timestamps are involved, which decides the preference of which node goes to execute the critical section first. Now let's take a look at Lampert's algorithm. Lampert's algorithm, also known as Lampert's distributed mutual exclusion algorithm, is a permission-based algorithm proposed by Lampert as an illustration of his synchronization scheme for distributed systems. In permission-based, timestamp is used to order critical section requests and to resolve any conflict between requests. In Lampert's algorithm, critical section requests are executed in the increasing order of timestamps. That is, a request with smaller timestamp will be given permission to execute critical section first than a request with a larger timestamp in this algorithm. There are three types of messages that are used to communicate between channels, and the order is FIFO. So the three ways are request, reply, and release, and they are pretty self-explanatory. A site or a node sends a request message to all other sites to get their permission to enter critical section. A site sends a reply message to request site to give its permission to enter the critical section, and a release message is sent to all other site upon exiting the critical section. So every SI keeps a queue to store critical section requests ordered by the timestamps. Request queue denotes the queue of site SI. That is, every node has a queue which stores the different timestamps every node is sending them. And the last 2 points says timestamps is given to each critical section request using Lampert's logical clock, and timestamps have the decides the priority of critical section requests. Smaller timestamps get more priority than larger timestamps. Now the last one is Ricart-Agrawala algorithm. I guess Mazhar has some network issues. We'll continue. Ricart-Agrawala algorithm is an algorithm for mutual exclusion in distributed system proposed by Glenn Ricart and Ashok Agrawala. This algorithm is an extension and optimization of Lampert's distributed mutual exclusion algorithm. Like Lampert's algorithm, it follows permission-based approach to ensure mutual exclusion. In this algorithm, we have two types of requests, or basically two types of messages: request and reply, and are used to communicate in different channels, and the order is same, which is FIFO order. So a site sends a request message to all other site to give permission to enter the critical section, and a reply message to another site to give its permission to enter the critical section. And the last 2 points says the same, that the timestamps are given on the basis using the Lampert's logical clock, and timestamp determines the priority of critical section requests. Smaller timestamps gets higher priority over larger timestamps. The execution of critical section is always in the order of their timestamp. So to conclude, I'll say what we have studied. We have studied what non-token based algorithms are. Basically, tokens are not involved, and timestamps plays a major role in deciding the node entering the critical section. And the two prominent examples of non-token based are Lampert's algorithm and Ricard-Agrawal algorithm. Lampert has three types of messages: request, reply, and release. And Agrawala or Ricard-Agrawala algorithm has two types: request and reply. Thank you.